good day. So today we will be discussing about energy recovery systems. So energy recovery systems play a crucial role in improving energy efficiency and reducing carbon emissions in marine diesel propulsion. So these systems capture and reuse waste energy that would otherwise be lost, leading to fuel savings, reduced greenhouse gas emissions, and compliance with environmental regulations such as MARPOL Annex 6 and IMO decarbonization targets. So as you can see in the picture, we have here an engine with a connection of a shaft motor. So if the engine runs, the shaft motor will produce electricity while giving also a rotation to the propeller for moving the ship. So that energy from the shaft motor can be, since this is a synchronous motor, so you can generate electricity, or you can use electricity from the power distribution unit to run the shaft motor, and then increasing the efficiency of the rotation of the propeller even without giving too much load on our diesel engine. Also, we have a turbocharger here that we have here the exhaust of our engine. That exhaust will help rotate the hybrid turbocharger, and then that exhaust will go to the economizer and then go into the atmosphere. And then while the hybrid turbocharger is also rotating, it will generate electricity to give power to our power distribution unit. And this, of course, if you have if you will be using electricity on board ship, so that will also give power to our usage. Also, we do have fuel cell or batteries on our board ship that we can also store those energy. And then after the economizer will generate steam. So there is water inside the economizer, and that water will boil since the exhaust from the engine will go into the economizer, and then those steam will be used to produce rotation on our steam turbine. And then since our steam turbine is connected to our generator, so this is called a turbo generator, that electricity will be produced and will give power or additional supply to our distribution unit. So that is an example of an energy recovery system. Okay, first, so let's go with waste heat recovery system. So the principle is it utilizes exhaust gas from the diesel engine to generate additional power. So that's what I've been talking on the previous page. So what are the benefits? It converts exhaust heat into steam to drive a steam turbine generator supplying electricity to ship systems. So it reduces reliance on auxiliary engines or generators, leading to fuel savings and lower carbon dioxide emissions. So it increases overall thermal efficiency from 40 to 50% in some cases. So many modern ships use exhaust gas economizer to heat water and generate steam, improving energy efficiency. So for example, in the picture here, we have the main engine in here, and then the exhaust that will be produced during the combustion of the main engine will drive the turbocharger, and then the excess heat will go to an economizer. So this is our waste heat recovery system. Since the economizer, there are water, boiler water, and other kinds of water that goes in inside the economizer. So it will heat up, and then it will generate steam, and this steam will be used, especially if it will be a high pressure steam, it will use to drive this flush turbine or steam turbine. Then after running the steam turbines, since it is connected to a generator, then the generator will produce electricity for the consumption of our consumers on board ship. Okay, so this is a picture of a container ship with engine room and casing arrangement. That one. So this is the engine in here, and then this is the turbocharger, and then exhaust go. Maybe they do have an SCR here or other equipments before going to the economizer and scrubber. Okay, next, letter B, shaft generator system. So principle, it uses mechanical energy from the main engine shaft to generate electricity for onboard use. So what are the benefits? Reduces fuel consumption of auxiliary generators, lowers greenhouse gas emissions, improves operational efficiency, especially during cruising speeds, and there are examples which is common in large container ships and LNG carriers, reducing auxiliary fuel usage by up to 10%. So these are the generators of the ship. We have 4 in this diagram. And then if the main engine is now running, so the shaft generator motor will also rotate. If the shaft generator motor will rotate, it will give supply to the ship service power. So all the generators can now be shut down because there is a shaft generator motor that will help in producing power to our consumption on board ship. Also, with the use of this exhaust gas, we can also run another design. So we can use put economizer, and the steam produced by the economizer will be the one that will run the marine turbine steam turbine generator also. And then this steam turbine generator will give supply to power for the ship. So our generators will be on standby at if that will happen. So your generator usage will be lesser than the normal, and it will produce many benefits for you and for the ship and the company. Okay, C, turbocharger energy recovery. So the principle is a power turbine extracts excess energy from the exhaust gases from the engine here. That exhaust gas will assist in driving the main engine or a generator. So it depends what is the connection, what will be what equipment to be connected to your turbocharger. So benefits, it enhances combustion efficiency and reduces fuel consumption. It reduces NOx emissions by optimizing air-fuel mixing. So it is used in two-stroke low-speed diesel engines, contributing to lower fuel consumption. So here is another turbocharger in which the other side of the turbocharger is not sucking air or intake air for the main engine. Rather, it has an alternator on the other side. So on this side, we have the inlet from the exhaust from the engine, and then it will help rotate this turbine, and then the exhaust will go to the funnel or to other equipment. And then since the turbine is running, so the alternator will also rotate, generating electricity for usage on our ship. So this can also be used for turbocharger. Okay, another types of energy recovery systems is the air lubrication system. This is ALS. So in principle, it injects air bubbles beneath the hull to reduce frictional resistance between the ship and water. So here we can see there is air lubrication system. So this is particularly used in cruise ships. So apart from reduction of frictional resistance, it also creates it also prevents vibration on the ship, so that the VIP customers that is in our cruise ships will not be disturbed by the different vibrations during the cruising of the ship. So benefits, it reduces drag, leading to 5 to 10% fuel savings, cuts CO2 emissions significantly, making ships more environmentally friendly. So an example is LNG, bulk carriers, but it is most common also in cruise ships. Okay, next. So this will be the cruise ship of the future. So they will be using liquefied natural gas, cleanest burning fossil fuel. They can also use fuel cell technology, can help reduce ship emissions. And the air lubrication system reduces drag. The no sulfur, lower nitrous oxides, and less soot. The water can be ingested And the power fuel cells produce supplied electricity on spacecraft. So this can also be used on our ships. So this will be the cruise ship of the future. Okay, another type of energy recovery system in marine propulsion is the freshwater generator. So in principle, a freshwater generator converts seawater into freshwater using the waste heat from the main engine cooling system or exhaust gas boiler. So this is done via vacuum distillation, like the picture above. We have the evaporator system, reducing pressure to allow seawater to evaporate at lower temperature, 40 to 60 degrees Celsius, condensing the vapor into fresh water. So this is a vacuum distillation evaporator system. And on the bottom, we have here the reverse osmosis. So in this is a kind of filter, forcing seawater through a semi-permeable membrane to remove salts and impurities. So often using an external power source. So if the clean water will be extracted, and then you can use this water on board ship. So we don't have to go to the land or to shore reception facility to get water. So benefits, this is another example. So for freshwater generator, benefit: uses waste heat, reducing energy consumption, reduces dependency on shore-based water supplies, making ships more self-sufficient, lowers fuel consumption and carbon emissions by avoiding additional power generation. So this is an example of freshwater generators, the evaporator system and the reverse osmosis. So we have here a diagram of evaporator freshwater generator. So this will we will make another video for this one, so because this will be another topic for us to discuss. Okay, so this is a picture of a reverse osmosis on board ships. Okay, so this will be its we will discuss this on another video. Okay, so that's it. So next we have here an enhanced turbocharger design in desalination. So this one, they are using water to run this. This is not an exhaust type turbocharger. This is a water turbocharger. So this is used to enhance desalination in our freshwater generators. So enhanced turbocharger desalination technology, pressure energy is recovered by the 80, so low pressure feed water in here that will help to run the this pump, turbocharger pump. And then on the other side there is a high pressure concentrate, and then you will put this into high pressure, this one. So from the high pressure pump, the fresh water, the seawater will be pumped into the turbocharger device, desalination technology, and then pushing those pressure, those seawater into the membrane, into a reverse osmosis membrane, forcing it, and then the clean water will pass through the membrane, while the dirty water or the impurities and salt and other unwanted materials or impurities will be removed by the suction side of the turbocharger, and then discharging it overboard. So this is another technology that can be used. Okay, next we have the another type of energy recovery system in marine propulsion. We have the gas turbine for LNG tankers. So principle, LNG tankers carry liquefied natural gas which continuously evaporates due to heat exposure. So instead of wasting this boil of gas, it is used as fuel in gas turbines, providing propulsion or electricity. So since these are their cargo, there are transferring LNG from one place to another, and since there will be some losses, like there will be some boil of gas that will be produced during the process of transportation or ship transportation, so it is very great to use it as another way to create recover some energy. So this combined gas turbine and steam turbine electric drive use gas turbine to generate power, while waste heat is captured for additional steam production. And so for dual fuel diesel electric, it uses both natural gas and conventional marine fuels, allowing flexibility in fuel choice. So the boil-off gas in here can also be injected into our main engines so that it will be used to run the ship. So less fuel consumption on your bunker, because you will be using the boil-off gas from the cargoes. Okay, benefit: it utilizes boil-off gas, reducing fuel waste, lower emission compared to diesel engines, meets IMO 2020 and MARPOL Annex 6 regulations on sulfur and greenhouse gas emissions. So that is another type of energy recovery system. Okay, another type of energy recovery system is the steam turbine generator. So it's the same with this gas turbine. So steam turbine generator, in principle, captures waste heat from the ship's exhaust gas boilers or waste heat recovery systems to produce steam, so which powers a turbine connected to an electrical generator. So steam is generated from engine exhaust heat. The steam turbine converts thermal energy into mechanical energy, and the generator converts mechanical energy into electricity, reducing reliance on auxiliary diesel generators. Okay, so benefits for this steam turbine generator, this one, steam turbine. So we have 5 to 15% fuel savings by reducing auxiliary generator usage. So lesser usage, lesser maintenance, and lesser manpower in maintaining those equipments. Okay, another one is lower carbon footprint, reducing CO2, NOx, and SOx emission. Improved energy efficiency, helping ships comply with IMO decarbonization goals. So we have here a picture. So this is our generator, and then here is our steam turbine. So this steam turbine will help rotate this generator so that we will have electricity on board. Okay, so this is a super turbo generating system. Okay, from the main engine. So the exhaust will go here to the turbocharger, running our turbocharger, and then going here. Another part of the exhaust will go on this one. So if you let this turbine rotate, so it is connected to the steam turbine, and it is also connected to our generator. Okay, so this exhaust will go to the economizer, and then producing steam. That steam will help rotate this steam turbine. Also here there is steam that will help rotate the steam turbine, and then the steam will go back to condensed state and then go back here and then recirculate to the system. And then if the turbine runs, the generator will also run, creating electricity for the ship. Or you can also use this one to run the turbine, and then run the generator. Okay, so shaft generator motor SGM. So we have here a main engine with a shaft generator motor, and then with frequency control, giving power to the management PMS, power management system. And also the steam turbine generator can also give power to our power management system. And then you can disconnect this diesel generator at the same time if you have the power already with the running equipments. And the load will be distributed to the ship load and to the containers or to the cargoes or wherever this electricity will be used. Okay, so this is another power management system. So it's the same. Okay, so this is its waste heat recovery system diagram. You can monitor here the kilowatts of each generator, the ship load. So you can use this one as the human machine interface, or your monitoring program. Okay. Okay, another type of energy recovery system in marine propulsion is the fuel cell and hybrid energy storage system. So we have here a generator. This generator will give power to the ultra capacitor, fuel cell, and battery. Or you can charge the battery, and then the battery can give power, the fuel cell can give power, the ultra capacitor can give power to our propulsion, to our load, or to our power management system, to the grid, or to the shore supply. Okay, so fuel cell and hybrid energy storage systems, stability of the onboard power distribution system, energy management strategy, control of hybrid energy storage system with batteries and ultra capacitors, the load scheduling and balancing, centralized power management system controlling all involved parts, and virtual commissioning and training platform for operators. This is another type of fuel energy recovery system. Okay, another type of energy recovery system in marine propulsion is a smart kite or kite powered ship. So this kite is AI controlled depending on the wind, the angle of the wind, the location, whatever. So if the kite will be pushed by the wind, also the ship will be pulled by the kite. So this will this will give energy recovery system in our marine propulsion, and then will give us savings in our fuel consumption. Okay, so the smart kite or kite powered ship, the smart kite is harnessing the wind to maximize the power. So maximum power up to 3 times more efficient than fixed sails. Wind strength increases with altitude. So it has control pod, tow rope. We have fuel consumption of so there is less in fuel consumption using this sky sail or parafoil, or depending on what's the name of the manufacturer of this equipment, or what their brand name. So this is another picture of a smart kite powered ships. Another type of energy recovery system in marine propulsion is the WASP, or the wind assisted ship propulsion. So it is like the times of Magellan, in which sailboats or ships are using the power of the wind to move their vessel. Okay, so in this one, there is a you can adjust the angle in here depending on the wind. So it will help your ship maneuver or increase to have savings in your fuel. So another type of energy recovery system. So this is a wind assisted ship propulsion, also integrated with a solar panel in front. So if you will not be using it, this can be folded down to prevent air friction during your voyage. Okay, this is another design of our wind assisted ship propulsion. So this is also automatically controlled. So they can use AI in this one to generate better propulsion for our ship depending on the wind conditions. So there's a mechanism that will help it rotate depending on the angle of the wind that it is pushing the ship. So this is another picture. So this sails can be, what we call that, can be retracted back inside if you don't want to use it. Okay, number 3, let's go with, so we're done with the types of energy recovery systems in marine propulsion. Let's go with the impact on environment protection and energy efficiency. So first, we have the impact of fuel savings, reduces overall bunker fuel consumption, lowering operational costs. Okay, another impact is CO2 and NOx reduction. So meets IMO's energy efficiency existing ship index EEXI and carbon intensity indicator CII requirements. And the third, and lastly, it extends equipment life, optimized energy use, reduces engine wear, leading to fewer maintenance costs. Okay, so what is the role of energy recovery in maritime decarbonization in 2050? So by integrating energy recovery technologies, ships can move towards net zero emissions, aligning with IMO 2050 goals through first, adoption of hybrid and fully electric propulsion systems, second, enhanced energy efficiency in LNG and hydrogen fueled ships, and third, reduction of operational carbon footprint. So IMO ambition is by 2030 there will be strict new build and operation requirements or moderate carbon pricing. By 2040, new builds and retrofits, a very strict design operation requirements or high carbon pricing. So we'll be using more on the liquid natural gas. And by 2050, 50% reduction in absolute emissions, 70% reduction of the carbon intensity. So that is the goal of IMO in 2050. So in conclusion, so energy recovery systems are essential in modern marine diesel propulsion as they reduce energy waste, enhance fuel efficiency, and minimize greenhouse gas emissions. So by optimizing waste heat recovery, shaft generators, turbocharger systems, and air lubrication, the maritime industry can achieve a more sustainable and environmentally friendly future. So as you can see in the picture, we have here a ship with the flow of waste heat energy recovery. There is optimization of engine system by 10%, reduction of friction drag by 10%, optimization of hull design also gives 2%, optimum voyage support system 5%, use of renewable energy by 0.1%, optimization of propulsion efficiency by 5%, use of fuel additives 1.5%, and optimization of engine system 10%. So a total of CO2 reduction of 30%. So, and the Wind Challenger project, so we can also reduce CO2 emissions by over 50% with the help of the Wind Challenger project. So we are on the momentum. So the shipping industry is in the momentum, and they will, or our shipping industry will never stop until we reach our 2050 goals. So I hope you learned something today, and if you want something some topics to discuss, you can comment down below. I'll see you on the next video. God bless and goodbye. Video na naman. Okay, bye.